So today is a paper 2 day. We'll do paper 1 again on Thursday. So today I thought we could go over a little bit of Euclidean geometry because it's not something that we've spoken about before. So I found the following questions for us to do. The first one here says, and I hope this is big enough for everybody. If you can't see it, I can try and make it bigger, but yeah, hopefully it's all right. So in the diagram, it tells us that PQRS is a cyclic quadrilateral. PS is produced to W. So in other words, all that means is that the line PS has been extended to point W. TR and TS are tangents to the circle at S and R respectively. Okay, so that would be an important thing to take note of. And T equals 78 and Q is equal to 93. So make sure when you are doing geometry that the very first thing that you do is read the information that comes with the diagram. All too often, we don't read the information, we look at the picture, we look at the questions, and then we get stuck. Okay, so most of the time, they put whatever information they've given you onto the diagram, but sometimes they might not. So it really is important that you read everything so that you know exactly what's going on. All right, so the fact that TR and TS are tangents, I'm sure is going to be important to us as we proceed through this question. All right, so if we have a look at the first question in 9.1, it tells us to give a reason why ST equals TR. So instead of me telling you, can you tell Melissa and I the reason why these two would be equal to one another? There we go, Panache. That's good. I don't know if everybody saw what Panache said, but that's perfect. Okay, and that's because they are tangents from the same point. Good, so tangents from same point. Good job. Okay, good, lovely. So now the next couple of things. In 9.22, the first thing they want us to do is calculate the size of S2. So how do you think we should do that? So S2 is this angle over here. Okay, so Razan said 51. Okay, but the thing is, guys, you're not going to get marks for answers only. Okay, so it's a process. You've got to put down, you've got to write down what's happening. Okay, so 51 might be the right answer, but we've got to tell a story. Okay, so we've got to provide a statement and a reason and get to it like that. So that's what we're after here. So interior angles of a triangle, absolutely. All right, quite right. Okay, so Cassandra, you're saying 180 minus 93. I'm not sure. Okay, so now Cassandra, hang on a second. Okay, ST is not an extension of the cyclic quad. So SW is, but ST is not. So what you need to do is you need to work inside the triangle. Yes, absolutely. Okay, you got to work inside the triangle. So the starting point here, if we want to get 2 out of 2, all right, is we need to say something about R2. Why does R2 equal S2? So hang on a second. Okay, so Palesa, you're saying the exterior angle of a cyclic quad, but then it would be this entire thing. It would be S2 and S3 that would be equal to 93. Okay, they just want S2. They don't want S2 plus S3. So if we have 2 unknowns, that's not going to help us. There we go, Palesa, you're on the right track about it being an isosceles triangle, although we're not allowed to use the word isosceles. The correct way for us to set it out is like this, okay? We need to say that S2 equals R2, okay? Because they are angles opposite equal sides. Okay, so that means that 2 of S2, plus 78 will add up to 180 because of the interior angles of a triangle or sum of angles in triangle. So 2s2 is going to be equal to 180 less 78, which is going to leave us with 102. Divide both sides by 2. And as you had said, s2 is going to be equal to 51. Okay, so that is the correct way in which to set it out. Okay, exactly. The tangent gives us a clue. Quite right. Okay, so because we've got tangents from the same point, that's what gives us the angles opposite equal sides. Okay, so there we go. And now we can work out what S3 is. And again, S2 plus S3 is the exterior angle of the cyclic quad. So we would have to say here that in 9.2.2, that S2 plus S3 is equal to 93. Our reason, exterior angle of cyclic quad. Okay, but we already know that S2 is 51. So 51 plus S3 gives us 93. So that means that S3 is going to be equal to 42. Okay, everybody happy with that? Yes, so S2 and S3 are the exterior angle of the cyclic quad. Quite right. Okay, so the two of them together make up the exterior angle. Okay, the angle on the outside. Right, and then in order for there to be an exterior angle to a cyclic quad, one of the sides of the quad has to be extended. Okay, so that's why S2 is not the exterior angle. S2 and S3 together are the exterior angle because side PS needs to be extended. Okay, so ST is not an extension of PS. All right, so it has to be along the same straight line. Is everybody okay with that? Any questions? All good. Okay. Let's go and have a look at the next thing. All right, so here we go. Next one. Let's just move this up here as well. Okay, so in question number 10, they've given us in the diagram, BE and CD are diameters of circle having M as center. Chord AE is drawn to cut CD at F, and AE is perpendicular to CD. Let C be X. All right, so the minute that we read the word diameters, what do we start thinking about, matrix? What comes to mind when you read the word diameter? There we go, Tsepiso. So if somebody tells you that there is a diameter, we start thinking, I'm just waiting for the right words. Does anybody want to put it up? Yes, it cuts the circle in half. Absolutely. 2 radii is also correct. There we go, Kanyesa. Angles in a semi. It's okay, Razan. You're trying, and that's all that matters. Angles in a semicircle. Does that ring a bell? Oh, okay. So it's Diana. Okay. Sorry, I'm calling you Razan because that's what it says on your thing. We need to change your name then. Okay, so angles in a semicircle, does that ring a bell to you? Yeah. So in other words, the diameter subtends a right angle at the circle. Is this familiar? Yes, no? Yes, okay, all right. So then in that case, which angle is 90 then? If the diameter subtends a right angle at the circle, Which angle is 90? Can you pop that into the chat for us? Okay, so Spoo says A2 plus A3. Sapiso says A. Palesa says F. Anybody else? Which angle is 90? Diameter subtends a right angle at the circle. So yeah, some of you are saying angle F, but angle F is 90 degrees because that was given to us. It's not 90 degrees because of the diameter. Okay, so what's also interesting is that some of you are saying angle A. Now, I just want to talk about this a little bit. All right, just one second. If you say to me angle A, all right, you mean the whole of angle A. We mean A1 plus A2 plus A3. Okay, now that is unfortunately not true. And there are some of you who have said the right thing. Some said angle A2 and A3. But look here. Here's the one side of the triangle. Here's the other side of the triangle. And there, drawn very badly by me, is the diameter. So it does not include angle A3 matrix. Okay, angle A3 is not supposed to be included in this. It's just A1 and A2 that are at the circle. Okay, so you have to call that either A1 plus A2. So we could say A1 plus A2. Or the other way that we could name this is CAD. CAD would be another correct way of naming it. Okay, that's it. All right, so there are Ani said that. Sapiso, you said that initially, but then you also said A2 and A3. Diana, you said A1 and A2, which is really good. Who else said A1 and A2? Bridget. Okay, so there are there are a few of you. So, Spusiso, you were saying, what about triangle AEB? Okay, well, triangle AEB. Yes, you're right. That also subtends a, oh, I see what you mean. Okay, all right. Sorry. Yes. I was just looking at the one. I wasn't looking at the other. Yes, quite right, guys. Okay, so angle A2 plus A3 also makes 90 degrees. Quite right, 100%. Okay, sorry, I was just looking at the yellow triangle, but quite right here. We've got another diameter which subtends a right. So equal to 90. Yes. Good. Well done, everybody. You're looking at this through good eyes. Okay, I'm really pleased about that. Well done. All right, so the first question says to us, give a reason why AF equals FE. Why does AF equal FE? So I'm just going to rub out what I've been drawing here, just so that I can highlight AF and FE for you. Okay, so AF is over here. Here is FE. Why are they equal? Let's see what you guys are saying in the trick. Okay, but Papa Bana, do they come from the center? Do they come from the center? They've got to come from the center of their radii, right? Okay, so I see some of you are talking about line from center bisect. Barlow, you've got it right. Okay, so it's not the same thing. Okay, line from center perpendicular to chord is the correct reason. Now, a lot of people get confused between these two. So if I may, can I just explain the difference between them to you? Just, okay. So, all right, no problem. So let me just draw two circles. Let's see if I can draw. Okay, I didn't really want it to be in. Okay, and then let me draw another one. Okay, let's get rid of this one. Okay. Okay, so we need the center of the circle in both situations. We need a chord in both situations. And in both situations, we need a line from the center. This is why it's so easy to be confused. So one diagram comes with a right angle. Okay, so what we are told, if that's O, the center of the circle, and that's A, and that's B, and that's C, what we have been given here, B is perpendicular to AC. Or they could say it like this. They could say OBA is 90. Or if they wanted to, they could see 90. What's important is that we are given that there is a right angle. We are then allowed to conclude equals BC, line from center to chord. Okay, so line from center perpendicular to chord is when we have been given the right angle. Okay, so we have to be given the right angle. The other one, we are not given a right angle. We are told that this line segment and that line segment are equal. So if that's A and that's B and that's C and circle center over here, what we are given here is that AB equals BC. What we are then concluding is that OBA is 90. We are concluding that OBC is 90. Or we could also put it like this. We could also say, or OB is perpendicular to A, or OB is perpendicular to AC. Our reason, line from center to midpoint of chord. Okay, now these are so similar that it's really very difficult for us to know the difference between the two. Okay, so when we have been given the right angle and we are concluding that AB equals BC, then it's line from center perpendicular to chord. Okay, when we've been given that AB equals BC and we're concluding that OB is perpendicular to AC, then it's line from center to midpoint of chord. Okay, do we feel a little bit better about that? Is that making sense to everyone? Okay, and so also I'm glad. Right, so that's the difference between them. The one comes with the right angle and the other one comes with the one line piece to the other line piece that are equal, okay, in the chord. All right, so if we have a look here, so the a right angle. So here we look at the question, are we given a right angle here? Yes, we are. Okay, all right, so the reason why AF equals FE is line from center perpendicular to chord. Okay, because the right angle is given. Line from center perpendicular to chord. Okay. Okay, so Maya, we use bisect if we've been given AF equals FE and we are concluding that F has a right angle. That's when we say bisect. Okay, so when we've been given the right angle, we say perpendicular. And when we've been given the midpoint, that's when we say line from center to midpoint of chord. Okay. All right, next question, 10.2. Determine the size of M1 in terms of X. Okay, so now we have to try and figure out the relationship. Okay, so you're saying a bow tie neck. Don't know if I see a bow tie here. Okay, remember the bow tie has to have both points on the circle. Okay, so maybe what we've got here is angle at center is twice angle at circumference. Can you see that? So in other words, this is what we're looking at. We've got the angle at the center. Okay, then arc CE also subtends an angle at the circle, doesn't it? It subtends A1 at the circle. Can you see that? So it's not strictly speaking the bow tie, it's angle at center is twice angle at circumference. Can you guys see that? Yes. So in other words, M1 is twice as big as A1. Right. So how big is A1? There we go. There we go, Makosandile. Okay, quite right. So this angle in here is 90 minus x. So the angle at the center is going to be twice as big. All right, so now we have to say all of this. We can't just write down the answers only and expect full marks when a question is out of 3. So the first thing that we have to do is explain why A1 is 90 minus x, and it's 90 minus x because of the sum of the interior angles of a triangle. Okay, because we know that f is 90, we know that c is x, so that means that A1 is 90 minus x. Now we're going to say that M1 equals 2 times 90 minus x. Angle at center is 2 times angle at circumference. Okay, and then we can conclude that that is 180 minus 2x. And I think somebody had something in the... And Tukosi, you said you're confused with the bisecting part. What do you mean you're confused with the bisecting part? Okay, so we're not using, and also in this one, we're not using angle from center to midpoint of chord. We're using angle from center perpendicular to chord. Anyway, I'll give you a chance to maybe write something in the chat. I'm going to go on to question 10.3, if that's okay with everybody. Are we all fine so far? Thumbs up, thumbs down. Are we feeling good? Okay, so there's a few. Okay, all right. Okay, all right, lovely. So let's go on to the next question, 10.3. So remember, geometry is a story. Okay, so the story is built, all right, from the first thing that we do and the second thing that we do, and everything from there is connected to one another. So we probably are going to use things that we've figured out in 10.1 and 10.2 to help us with 10.3 and 10.4. I say probably, we'll have to wait and see what happens. Okay, but more than likely. Now they want us to prove giving reasons that AD is a tangent to the circle passing through A, C, and F. Okay, so now this is a difficult question. All right. the circle passing through A, C, and F is not drawn. Okay, so let's just rub that out. And let's just put in here, we know that this is 90 minus x. And we know that that is 180 minus 2x. All right, we're going to see if we need to use that now. So if we want to prove that AD is a tangent to the circle, all right, here is AD over here. And it tells us that the circle passes through A, C, and F. All right, so when we see that, what reason do we use to prove that a line is a tangent to a circle? Does anybody know how to prove that a line is a tangent to a circle? Can you remember from grade 11? Sibusiso, you're very close. Okay, very close. Let's see what the others are saying. Okay. Do you remember converse tan chord theorem? There we go, Sibusiso. Converse tan chord theorem proves that a tangent is a line to a circle. Okay, so converse tan chord theorem. Okay, so in other words, we now have to prove that there are two angles that are equal to one another, all right, in order to prove converse tan chord theorem. Okay, does anybody know which two angles we are talking about? Which two angles do we need to prove are equal in order to prove C and A2? Mako Sindile, that's very good. Matome, A2 and C, very nice. Oh, I'm super, super, super impressed. Okay, that's really, really good. Well done, good spot. Okay, because remember, AD is going to be the tangent. AF is the chord. Okay, so angle A2 is going to be the angle between the would-be tangent and the chord. All right, and the angle in the alternate segment is going to be C or X. That's really, really good. Just being able to identify which of the two angles is excellent. Okay, so I'm really, really chuffed about that. So we need to prove that A2 is X, is essentially what this question is asking us to do. All right. No, AF is the tangent. Sorry, AD is the tangent, AF is the chord. Okay, Nick. All right, AD, we're going to prove is the tangent, and AF is the chord. Okay, and then the chord subtends C in the alternate segment. Okay, so in other words, now we have to prove that A2 is X. How are we going to do this? How are we going to show that A2 is X? Anyone got any ideas? Goes back to what we were talking about in the very beginning about which two angles make 90. M1 equals 2 of C. No, M1 equals 2 of A1. Sibusiso. Okay, so M1 is the angle at the center and A2 is the angle. There we go, Matome, Makubela. A1 plus A2 equals 90. Very, very, very good. Why? Why does A1 plus A2 equals 90? Yes, Ntukozo. A1 plus A2 equals 90. What's the reason for this? There we go, angle in a semicircle. Okay, but we've already proved that A1 is 90 minus X, haven't we? So that's why I'm saying we always use the stuff that we've got. Okay, so we've already worked out that A1 is 90 minus X. So if A1 is 90 minus X plus A2 is equal to 90, then if we took the 90 over to this side, it would cancel out. If we take the X over to the other side, A2 would be equal to X. Does that make sense to everybody? Does that make sense? Okay. So we've proved, oh God. All right, so we've proved, whoopsie daisy. What have I just done? Sorry, I don't know what I clicked on there. All right, so we have proved that A2 is equal to X. So A2 is X and C is X, because that was given to us. Okay, so therefore, A2 equals C. Very important for us to conclude that those two angles are equal. Therefore, AD is a tangent. Converse. Tan chord theorem. Okay. Does that make sense to everyone? How are we feeling now? All right, so there's 10.3 done. Yes, Kanisa, I can. All right, so let me just go down here. Okay, so let's draw a circle. Let's draw a straight line. Okay, just give me a second here. And now I'm going to draw another line. And now I just want one more line. Okay. So in the situation that I have over here, let me call this T, A, N, B, C. So if I am given or have been able to prove that TAN is a tangent to the circle, then I am allowed to conclude that the angle between the tangent and the chord, so here's the tangent is in pink, the angle between the tangent and the chord is in blue, is equal to the angle in the alternate segment. So chord AB sub 10C at the circle. Okay. Then the angle between the tangent and the chord, in other words, BAN equals C. That's tan chord theorem. So you are given that the line is a tangent to the circle, Kanisa. Okay, they tell you that, or you've been able to prove it previously. Okay, that's when you use tan chord theorem. Okay, but you have to be told that the line that is touching the circle, yes. So if you had said tan chord theorem up here, and you hadn't said converse tan chord theorem, you would be marked wrong. Well, you wouldn't be marked wrong, but well, you would lose a mark. Okay, so if everything else that you had done here was correct and you left off the word converse, then you would get 3 out of 4 and not 4 out of 4. Okay. All right, so tan chord theorem and converse tan chord theorem mean two different things. Okay, so tan chord theorem means you have been told that the line that touches the circle is a tangent. Okay. In converse tan chord theorem, what we are trying to do is we are trying to prove that the angle in the alternate segment is equal to the angle that would lie between what will be the tangent and the chord. So if you compare that to what we had said over here, okay, there's no circle drawn. What we're trying to do here is we're trying to prove that A2 equals C in order to prove that AD is a tangent to the circle. So we are not given that AD is a tangent. Okay, that's when we've got to use converse tan chord theorem. Okay, so we can't use what's true to prove that it's true. So this is a bit of a, not a very nice way of putting it, but like, let's say someone had committed a murder. You can't say the person is guilty because we think they're guilty. They're guilty because their fingerprints are on the weapon, or the victim's blood was found in their house, or their fingerprints are all over the weapon, or it was their gun that shot the victim. Do you understand what I'm saying? So there've got to be other reasons why the person is guilty. They're not guilty because they're guilty. They're guilty because of other things. So it's the same thing here. We can't say it's true because we're proving that it's true. We've got to find other reasons to prove that it's true. So in this situation over here, we have been able to show through other reasons, in other words, that the sum of A1 and A2 is 90, and that means that A2 therefore has to be equal to X. Now we've proved the two angles are equal. Now we can conclude that AD is a tangent to the circle. Okay. Oh, so there has to be evidence, quite right. Okay, so you're not guilty because you're guilty. Okay, you're guilty because there's evidence that proves that you did it. Okay, so man, absolutely. It just, in the lady, it just depends on what they want you to do. So sometimes it could be something like this, where it's angles in the same segment. There could be a couple of different things. Okay, but any situation where angles are equal would be a way to be able to prove it. Okay, no problem, Kanisa. I hope that makes sense to you. All right, let's try and do 10.4 now. It's a pleasure. It's a pleasure. It's a pleasure. Okay, so now on 10.4, now they're telling us that CF is 6. What? Let's put that on. So CF is 6 and AB, where's AB? Oh, there it is. AB is 24. So that's this line down here. So now, so this is AB here. All right, and this one over here is 6. Calculate, giving reasons, the length of AE. Okay, so again, go back to the beginning. Remember, we know that AE is AF plus FE, and we know that AF and FE are equal to one another, don't we? Okay, because of line from center perpendicular to chord in 10.1. We know that AF equals FE. So there's got to be some reason as to, well, using that as to why, well, as to how we're going to calculate the length of AE. All right, so let's have a look at what they've given us here. So we know that AF equals FE. That's one bit of information that we've got. Okay, this is what they want us to see here. Okay, now this is the bit that's a little bit difficult to sort of try and visualize. What I'm going to have to do is let me just rub the green off just to, all right. This will just, now that we've got rid of the other thing was a little bit distracting. Okay, so we've now got to try and think about the other information that we've got in this triangle. Okay, so in this diagram. So we know that AF equals FE. All right, and they've told us something about AB over here. So that's this line over there. All right, we also know that BM equals ME. Why does BM equal ME, Matrix? Why does BM equal ME? There we go. Exactly, because they're radii, aren't they? Absolutely, 100%. 100%, guys. So what's going on here? We've got a triangle, the blue triangle. We've got the midpoint F. We've got the midpoint M. What does that mean for us? So we've got a triangle and we've got two midpoints. What are we doing here? A triangle with two midpoints. What does this mean? This goes back to grade 10. It is proportion. It is proportion, Maya, but it's a special type of proportion. Okay, with midpoint theorem. Do you remember midpoint theorem? Okay, so midpoint theorem is proportionality intercept theorem. It's just that the line that's drawn parallel to the third side of the triangle cuts exactly midpoint theorem. Okay, from grade 10. Naledi. Okay, so maybe I should just talk a little bit about that as well. So midpoint theorem in grade 10, I'm sure you'll remember it when I start talking. Okay, so there we go. We've got a triangle, right? Now, we have a line from one side. Sorry, that's supposed to be a straight line, badly drawn by me. A, B, C, and let's call that D and E. So in other words, if you've got AD equals DB and AE equals EC, so you have to be given two midpoints. Okay, so AD equals DB and AE equals EC. That's given to us. Therefore, we are allowed to conclude two things. First thing that we're allowed to conclude is that DE is parallel to BC. The second thing we're allowed to conclude is that DE is half of BC. Midpoint theorem. Is that ringing a bell? Oh, shame, Diana. Okay, but your teachers should have touched on it when they did proportionality intercept theorem with you. They should have been some sort of mention of this, because really this is proportionality intercept theorem. It's just that we're working with midpoints. Okay, so it's the same idea, more or less. Okay. It's okay, no problem. So can you see how everything that you've learned, and this is shame, this really is where you guys are at a disadvantage because of what happened in COVID, and you were in grade 10 that year and you missed out on a lot of important information. But this is where you can see that everything that you've done in grade 8, grade 9, grade 10, grade 11, all comes to support what you're able to do now. Okay, so whoever would have thought midpoint theorem, but here we go. All right, is AB equal to AC? Not necessarily. Not necessarily. Okay. Right, so in this situation, it would have to be because my two parallel lines are exactly horizontal, but no, it doesn't need to be. So in other words, I can have a triangle that's slanted. So let's say I've got that. So now you can see that those are very definitely not equal to one another. As long as I've got a midpoint here and a midpoint here, I've got midpoint theorem. Okay, so now this line over here, let's call this one AC. And let's call this one AB. Now you can see that AB definitely does not equal AC. Okay, so it's not about the two line segments being equal to one another. It's about the fact there are two midpoints. Okay, all right, so over here in both of these, D and E are the midpoints on AB and AC respectively. Does that make sense to everyone? Are we feeling good? Yes, okay. All right, so now let's go back up here and let's go and talk about what we can see here. All right, so because AF equals FE, because of line from center perpendicular to chord, and BM equals ME because they are radii, what can we say about FM and AB? Exactly, they are parallel, quite right, Spoo. They are parallel and, so sorry, Diana, I'm saying that if AF equals FE because of line from midpoint perpendicular to chord and BM equals ME because of radii, what can we say about FM and AB? Quite right, intercausal. Yes, they are parallel and FM is half of AB. Kanisa, you've nailed it on the head. Beautiful. Perfect, perfect, perfect. All right, so now we know how long FM is, don't we? Okay, so we now know that FM, we're going to put all of this down on paper. We'll just talk about it first. So now we know that FM has to be equal to 12, doesn't it? FM has to be equal to 12. Right, so what do they want us to work out the length of? AE. AE. And we know that the triangle that we've drawn this blue thing around, we know that it's a right angle triangle. Because remember, you guys in the beginning, you were telling me angle A2 and A3 are also 90. Okay, so that's important. Okay, so if we know that CF and FM are 6 plus 12, that means that one radius of the circle is how long? Because remember, BM is a radius, ME is a radius, but MC is also a radius, isn't it? MC is also a radius. Can you see that? So MC over here is also a radius. Can everybody see that? Yes. All right, lovely. So now we know the length of a radius. So if we know the length of a radius, we know the length of BME, don't we? Because BM has to be 18 as well, and ME also has to be 18. Does that make sense to everybody? Exactly. AE is equal to 36. Yes, because it's from the center, quite right. No, so BE is going to be equal to 36. AE, we're going to calculate using the theorem of Pythagoras. MC is 18, yes. No problem. Ibrahim, what I'm going to do is I'm going to put it all down. So let me just get rid of this, because I don't think we really need any of that. Yeah. Okay, so Ibrahim, no problem. Okay, I understand that this is a lot to digest. There's a lot going on in this picture. Okay, so Ibrahim and anybody else who was a little bit confused. All right, remember in the beginning, we had said that AF equals FE. We'd already proved that up here. That was line from center, perpendicular to chord. And we had said that BM equals ME because they are radii. So in other words, we have two midpoints. F is a midpoint and M is a midpoint of the triangle that is colored in blue. Because of that, that means that FM is equal to half of AB because of midpoint theorem. Okay, and we know that AB was 24, so that makes it 12. Okay, so FM is 12 and CF is 6. We've been given that. Okay, so we've been given that CF is 6. So the entire length of the green line, which is a radius, because it goes from the center M to the circle C, is 18. So CM is 18. Okay, so therefore, BM equals 18 and ME equals 18. Okay, because all three are radii of the same circle. Okay, so CM is a radius, BM is a radius, and ME is a radius. Does that make sense, Ibrahim? Pleasure. Okay, so now we know, so now we're looking at the blue triangle. Remember, it's right angle. You guys told me that. You guys were the ones that pointed out to me that angle 2 and angle 3 makes 90, which was perfect. It certainly does. So that means we can use the theorem of Pythagoras, okay, to work out the length of AE. Okay, so because we've got AB and now we've got EB, haven't we? Because EB are 2 radii. Okay, so it's going to be 36. Shame, Nick. You're nearly there. You're nearly there. Okay, so let's just finish this off. So now we want to say AE squared. All right, I'm just going to rub this stuff out here. Give us a bit of space to write.
Sorry, ma'am, while you're still explaining the last part of the question, can I please run the poll?
Sure.
Okay. So please, Matrix, just answer the polls as it pop up in your screen. Thank you.
There we go, Spoo. Okay, so AE squared, so AB squared we know is 24. And BE squared we know is 36. So now we've got to say 36 squared minus 24 squared. So that gives us 720 for AE squared. And then we've got to take the square root. Okay, so I get 12 root 5. And if you want to press the SD button on your calculator, that would give us 26,83 units. Okay, rounded to 2 decimal places. Okay. Is that making sense, everyone? Oh, I'm so glad. Good, 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 good. Good job, everybody. I'm glad. Okay. All right. So yeah, please answer the poll. Thank you so much. All right. And just remember, Matrix, they're never going to ask you anything that you don't know, that hasn't been taught to you. So you're not going to be expected to know things outside of your curriculum. Everything is going to be based on something that you have been taught. So when you look at these questions, you have to think about the things that you know that you can relate it to. Okay. It is all about understanding and being able to read the clues, isn't it? Maya, you're quite right. ME is a radius because M is the center and E is a point on the circle. Quite right. No, ME is a radius. BM is a radius, ME is a radius, and CM is a radius. And in fact, MD is also a radius. You know, we just didn't end up using it, but oh, it's a pleasure, Diana. Oh, I'm glad you found it really helpful.